Alright, continuing with 9.3, question number 5. D, E, and F are the midpoints of the sides BC, C, and AB of a triangle ABC. So you can always see the triangle, right? And D, E, and F are the midpoints of these three sides. Okay, works to prove all these three. So write on a given to prove construction. We will join these three lines. Alright, now let's start with the first proof. BDEF is a parallelogram. Okay, so you can see the red lines, right? Now the question is given to us that what? E and F are the midpoints of the side AC and AB, right? Which means from the midpoint theorem we can say that this line EF is parallel to this line BC. Okay, but here we'll be taking EF is also parallel to BD. Why? Parts of parallel lines are parallel, right? And also we can say from the midpoint theorem that EF is half times BC, right? And half times BC will be taken to be equal to BD. Alright, so you can see here EF is parallel to BC and EF is parallel to DB. Parts of parallel lines are parallel, and EF equals half times BC, right? But this half times BC will be taken to be BD. Why? Because we need this side BD. Right, okay, and then now we'll go to the next again. Once again, the question has given to us a what? That is D and E are the midpoints of the side AC and BC again, right? Which means we can say that this line ED is parallel to this line AB, but we'll take it to be again ED is parallel to BF. Okay, and also ED is half times AB, right? But that half times AB will be taken to be equal to BF. All right, once again because we need that side. All right, so this we can see here DE is parallel to AB, and then DE is parallel to BF, right? Parts of parallel lines are parallel, and then DE is half times AB, but this half times AB we will take it to be equal to BF, right? Now if you compare these two, equation 1 equation 2, can you see that what? EF is parallel to DB, EF is parallel to DB, and also EF equals BD, EF equals BD, right? And from equation 2 we're getting that this ED is parallel to BF, and also that ED is equal to BF, right? So from these two equations we can say that BDF is a parallelogram. Why? One pair of opposite sides, right? One pair of opposite sides are equal and parallel to each other. All right, let's go to the next. Now area of DEF, they're going to prove that this area of DEF is 1/4 times the area of ABC. Okay, so now this one, okay, we know the diagonals of a parallelogram divides it into congruent triangles. Congruent means equal, right? And equal triangles should have equal areas. Okay, they will have equal area. Now from one we have proved that what? BD, that this BD EF is a parallelogram, right? Now can you see that this is a diagonal here, right? So the diagonal divides into two equal triangles, which means this area should be equal to this area. All right, that is what I'm writing it down. DBF equals area of DE. Yeah, right. Also we can prove that FDC is a parallelogram. Okay, FDCE is a parallelogram. We can prove this, right? We can prove this, and also you can see that the diagonal is here, which means these two areas should be equal again. All right, now once more after that we can also prove that AFD, right? This AFDE is a parallelogram. Okay, and you can see there's one more diagonal here, which means these two areas should be equal, right? So that is what we're writing it down here, right? Now when you look at this equation 3, 4, and 5, can you see that the right hand side are all equal, right? DF, DF, and DF, which means even the left hand side should be equal, or in other words all the areas are equal to one another. Okay, so you can see here from 3, 4, and 5 we're getting that all the areas are equal to one another. Clear? Now when you look at this triangle again, triangle ABC, can I say that this triangle ABC is made out of this area plus this area plus this area plus this area, right? That's why I'm writing it down. DBF, DEC, AFE, and DF, they all make up this entire area of this triangle ABC, right? But from 4 we know that all the areas are equal to one another. Okay, so I'm taking it all to be equal DF, 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 and DF. So we have 4 DF, right? So 4 times area of DF equals area of ABC. This 4 will go down, this 4 will go down to the denominator, and that is how we'll have the proof that we need. Okay, area of DF equals 1/4 times the area of ABC. All right, now the last proof, area of BDEF equals half times area of ABC. That is what they're asking us to prove, right? We have already proved that what? this BDF is a parallelogram, right? And now because of this diagonal, we know that what the area of this parallelogram BDF is made of this area plus this area. But we know that what diagonal of a parallelogram divides into congruent triangles, equal triangles, and then equal triangle or congruent triangles have equal area. So I'm making use of DEF and DF. Okay, in place of DBF I'm writing it down DF because they're equal, right? Okay, now DF plus DF I'm going to get 2 times DEF, right? But we have already proved that what previous proof that DF equals 1 by 4 times the area of ABC. Okay, so in place of DF I'm writing it down 1 by 4 times the area of ABC, and 2 1s are 2 2s are, right? Which means I'm going to have area of BDEF equals half times the area of, right down here, area. Okay, here 1 by half times or 1 by 2 times area of ABC.